This is part 2 of the touch switch series. If you haven't seen part 1, click on the link above. I'd recommend watching that first and you'll know what's going on. So basically what's changed since part 1, I've replaced the 555 timer with a Pic Microcontroller. I'm using the Pic 12F675, which has the same footprint as the 555 timer. And also we've got some mains in now, so we've got mains in here going through switch mode power supply. I went for a brought one in the end from DigiKey rather than design my own, because at least you know with these ones I got all the safety standards that are recommended in the UK. Excellent isolation over 200 meg I believe. So obviously we've got the 240 volts going in and 12 out. I've got a Zener diode up there dropping the voltage down to 5.1 for the Pic. So as it is now, it's got two forms of operation. We've got the toggle mode, which it's in now, and a timer mode. The timer mode range from 2 minutes up to 30 minutes. I think that's what I've programmed it to do. So we're in toggle mode at the moment, which we've got pin 6 I believe is low at the moment, so we'll change that over to high. We can go in toggle mode. I think I got that set on at 2 minutes at the moment, I can't remember. So yeah, it looks a bit of a bird's nest, but I purposely did it like this. You know, I've designed it so we got antennas all over the place, and I've actually managed to get it running perfectly now like this, so at least I know that when it's on a PCB I'm not going to get any issues with external influences on the actual touch switch part of the circuit. So there it is. I've captured a schematic on Altium, which I'll show you in a moment, and yeah, there's a time switch that's gone. So what I'll do, put that back over to toggle mode. So yeah, like I said, I've captured it on Altium schematic, and I've put the actual PCB together ready for printing. So what we do now, we just hop over to the computer and I'll show you. So there's a schematic capture. I hope you can see it because I'm actually recording the screen of my TV. So yeah, there's not a great lot of difference from part 1 schematic that I hand drawed. There's a few differences. Obviously I've got some bypass capacitors I've put in. A bit of MOV protection before the on the main side of the switch mode power supply. It was actually recommended in their documentation, because I don't think it has, because of the size of the footprint I think they're working on, so there's no harm banging one in. If you don't know, basically they work very similar to a Zener diode, so you know, if we get any high transient voltages from the mains, it's just going to clamp it down and filter it through back to the main side, rather than putting nasty glitches into the switch mode and destroying the components on the low voltage side. So what else we got? Yeah, so as you know, we're using the LM358 dual op amp. Actually I've got an unused one there, and that's actually the correct way to actually terminate them out if you're using a single supply, which I am. We've got the switch at the top there, which is basically at the moment it's pulling pin 6 high, switch it in it to take it low for the operation. The 10k pot, I'm using a analog in on the Pic, and basically programmed it, you know, if it sees this voltage turn on the light for X amount of time. I'll probably show you the actual my programming code in part 3. There you go. Oh yeah, I have changed the high power N-channel MOSFET to a 2N7000. And I did forget to mention earlier that I think on part 1 I had it as a gain, I had the op-amp gained at 37, but I've actually dropped it down to it's got a gain of 13 at the moment. 37 was a bit too much for this small signal MOSFET. It was going crazy, but as it is now, a gain of what gain we got? 10k, yeah, I think a gain of 13. It works well. I think that's it. We got the relay here, the little 12 volt coil relay. You can manage up to 10 amps, which is more than enough domestic. And I think that's all I need to show on that. Let's have a look. Anything else? No. There's a small little description down here. So now I'll show you the actual PCB I put together. There's the PCB. I didn't really want to do a video showing you how to put all this together, so I don't want to be biased towards one program, because this is Altium. Not everyone has Altium, so I don't really want to talk too much about the operations of the actual software. Anyway, blabbering on. So I've designed it to go into a switch plate. This is an old dimmer switch plate I had lying about, so that's that. And the touch sensor is going to be in the middle. The touch sensor is going to be in the middle. We'll have the pot and the switch actually poking. I'll drill a couple of holes here and have them poking out here. And this is going to be the switch I'm going to use. It's just one I scrounged, salvaged from another timer switch I had. What else can I say about that? It's very important to keep good separation from the DC side and the mains in. This one I'm going to do a DIY print on this using dry photoresist film. And I think what I'll do, I'll just score in a nice little cut out there just to give us more isolation separation from the high and low voltage circuits. What else can I say? Part 3, we get this printed out on some dry film. That's the method I'm going to use. Get that developed and hopefully get the components on and testing. There you go. Now I'll just show you, for those of you that are interested, I'll actually show you the switch mode I'm using and the relay just here. This is what I'm actually using. You can see that. Yeah. It's a very low power switch mode power supply, but I'm only using tens of milliamps. I think this one's rated at 160 milliamps at 12 volt, about 25 milliamps 240, which is more than enough. It's quite small, you know, you're looking at 35 millimeters, I think, by 20. And again, with the small relay I'm using there, that's tiny as well. That's 15 millimeters by 8, I believe. You know, it gives me loads of space to work with. So there you go. So hopefully I'll catch up with you guys in part 3. Ta-ra for now.